Greetings, judges. This is Team AI Wall. We are presenting Documind, our code maintenance AI Agentic AI Hackathon solution. So I'll quickly go through the problem first. What happens is that whenever a developer creates a new feature to the code or anything new, update the code, they have to maintain the code as well. By maintain, I mean usual things like test cases, documentations, architectures, and all those things they have to maintain. So they have to put some time in these things as well, along with developing new features. So while they put this much time in these maintenance things, they get less time to create new features. So we are trying to autonomously solve that by creating a asynchronous process where whenever a developer creates a pull request, so pull request is the time where new code is getting pushed to a branch. So whenever a developer creates a new pull request, they add some changes. So we see that there is a dummy pull request where there are four files, those are changed here. So we this is the new code which, let's say, a developer has pushed. So now we want to autonomously generate the documentation part of it, and by documentation I mean test cases or swagger, all those things. So for our document to work, there is a need to add document.yaml file in the project. Document.yaml file consists of many things like the version and monitoring branch, but major things are PR label. This is the label. When we put this label on the PR, our agent will work, and the features. So whichever feature which are turned on by the developer, only those features will be consumed by our agent. So test cases and swagger. Swagger is an API documentation. So we will be performing API documentation and swagger for them. Now let's continue. I'll show it's working. We have these two servers running. So once I have, first I'll start this process and then I'll go through how it works. So let's put this label as I showed document review. Whenever I pull this label on this PR, we see that this label has been added and it has received the label event. Now the agent is working its thing. So now let's go through the architecture, how it works. So we have a Git client. So currently it is GitHub, but our project is configurable for GitLab, GitHub both, and even more. Then there is a cloud function. This cloud function is a secure entry point where we check all the signatures and the correct Git client from where it is coming from. We use PubSub to maintain the messages and try the retries. We have two servers running. First is a backend server and an agent server. Agent server serves our agent. The reason for us to keep these two things separate is because these things scales differently. Agent scales differently based on the CPU consumption, while the backend server scales differently because it consists of tools and other dispatching things. So let's go through how the architecture works. We will see. So we saw that a pull request was raised. When we labeled this pull request, we intelligently dispatch. So there is a multi-agent system our solution is working on. So we have to intelligently dispatch the context. So in order to give appropriate context to each agent while removing any secrets or anything secured from that content, our agent then process it and autonomously generate the things which we commit back. So now let us go through some costing part of it, as this is crucial because of the AI solution. We'll just quickly check. Yeah. So we'll see that a cost analysis of the document. We are using 2.5 flash right now, and this is a monthly costing overview with considering 5 developers. So now let's say 5 developers monthly cost for input tokens are coming around $50. So these are all real estimations we see from our agent, and output tokens cost comes around $40, and vector cost comes around this much. So overall total cost come around $116. That is for five developers. We divide it by five and we get around $23 per developer per month cost. While we see this much, we save around 8 hours per month of a developer. And if we consider $50 for a developer, then we see significant cost saving of $1,600 around. And when we reduce this much amount, we see that around $1,500 are getting saved. Now this much cost is getting saved, and if we reduce 10%, around 10% margin from it, still we get around $1,300 saved. So that is a great saving. And we calculate this saving by actually estimating how much developers time is getting saved. So now this agent, so I'll go with the time consumption of the agent now. How much time does the agent takes? So as we saw, there is a file, document.yaml file. When we see that file, we see the list of features mentioned here. So as a developer turns on the feature, it that the time depends on these much features. If all the features are turned on, we saw around 10 minutes of average time that is being consumed by the agent. While right now there are two features on, so we see it should take around 6 minutes of time to actually perform the task. When it completes its tasks, it will actually commit back to this pull request, so developer doesn't need to do anything. We see the last event is actually labeling event, and we will see now when the agent will commit back that so this is working, and we'll see a new commit here that is from the agent, and it will show the changes made by the agent. So we see that it just there is a new change and it just committed this commit. um, we will see. So as we were saying, the swagger or API documentation feature was turned on, so that is why we see a YAML file of open API. It has successfully generated this much content, and for user routes it also has generated this much test cases. So we are seeing, so it has generated around 400 plus 300, around 700 lines of code for a developer. So that is the this is the actual use case where we consume these agents to actually save a developer's time. Thank you.